All right. Hello, everyone. Welcome to lesson 1.4. This is going to be a lesson on solving inequalities. My name is Mr. Teal, and let's go ahead and get started. We're going to start with a couple of vocab words and some properties of inequalities. And we're going to go into some examples a little bit later on. So if you remember back from Algebra 1, inequalities are the less than, greater than, or equal to symbols. We know how to work those. We know how to order the symbols to show that one number is greater than a number. Now, today we're going to introduce properties of compound inequalities. And so we're going to get a little bit more involved with that concept. So let's go ahead and get started. First of all, by joining two inequalities together with the word and or the word or, you are creating a compound inequality. So if we're taking two separate inequalities, two separate statements that have inequality symbols in them, and we're joining them together, then we are creating a compound inequality. Now, before we go more into compound inequalities, let's go over some properties of the inequality. So the first property I'd like to talk about today is the transitive property. If we have A is greater than B and B is greater than C, then we have A is greater than C. An example of this at work. If we had 6 is greater than 4, we know this is a true statement. And we know that 4 is greater than 2. So these two numbers, see how they're the same? 6 is greater than 4, 4 is greater than 2. Then we know by the transitive property that 6 is greater than 2. So the outside numbers are still going to hold. The outside number is going to be greater than this outside number if these two numbers are the same. So essentially, if we have A is greater than B and B is greater than C, we do not need the middle numbers anymore. We can say bye, and all we need is 6 is greater than 2. All right? Now using addition. So if A is greater than B, then A plus C is greater than B plus C. Now go ahead and keep in mind here, if we are adding C, that means we are adding the same number to both sides of the inequality. If we add the same number to both sides of the inequality symbol still holds true. So for example, if we have 5 is greater than 3, we know that's a true statement. If we were to add 2 to both sides of that inequality, so say 5 plus 2 is greater than 3 plus 2, we know that this is going to be a true statement because of the additive property, the addition property. So 5 plus 2 is 7. And we know that 7 is greater than 5, which is 3 plus 2. So we know that this property does, in fact, work. Now, the same can be held for subtraction as well. So if we have A is greater than B, then A minus C is greater than B minus C. So essentially, if we were to subtract C from both sides of the inequality symbol would still hold true. For example, if we have 7 is greater than 5, we know that's a true statement. If we were to subtract, say, 3 from both sides, so we have 7 minus 3 is greater than 5 minus 3. If I were to do the math here, 7 minus 3 is 4, and we know that 4 is greater than 5 minus 3, which is 2. So that means the subtraction property does hold true for the inequalities, okay? Now moving down to multiplication. So there are a couple of different conditions for the multiplication property of inequalities. So the first condition, if A is greater than B and C is greater than 0, so essentially if C is a positive number, because all numbers above 0 are positive, then A times C is greater than B times C, okay? So let's take a look at this. For example, if we had 6 is greater than 5, and we also know that, let's assign C to be 2. So if 2 is greater than 0, C can be any value that's above 0. So for example, if we had 6 is greater than 5 and 2 is greater than 0, then A times C would still be greater than B times C. So we'd have 6 times 2 would still be greater than 5 times 2. And that's a true statement, right? Because 6 times 2 is 12. And I know that 12 is still greater than 5 times 2 is 10. So that means it's a true statement. This property does hold true. Now on the alternative, if A is greater than B and C is less than 0, so essentially if C is negative, the same property holds, but the symbol is flipped. So we have A times C is less than B times C. For example, if we had 4 is greater than 2, so we're saying A is 4, B is 2, and let's say that C is some negative number, let's say -5. -5 is less than 0, okay? Then we know that A times C has to be less than B times C. So essentially, 4 times -5 is going to be less than 2 times -5, okay? And we know that's true because 4 times -5 is going to be -20. -20 is less than 2 times -5, which is -10, all right? Now moving on to the division property. So similar to the multiplication property, but slightly different. If A is greater than B and C is greater than 0, so once again, if C is positive, then we have that A divided by C is greater than B divided by C. So let's go through an example. Let's say A is going to be 8. We know A is greater than B. Let's say B is 2. And let's say C is also 2. So I'm going to say, and C is 2. 2 is greater than 0. So if we have 8 is greater than 2 and 2 is greater than 0, 2 is positive, then A divided by C is greater than B divided by C. So let's test that out. 8 divided by 2 has to be greater than B divided by 2, which is going to be 2 divided by 2. 8 divided by 2 is 4. And 4 is still going to be greater than 2 divided by 2, which is 1. So that means, yes, this does work out. Now going down here, if A is greater than B and C is less than 0, so essentially if C is negative, then we know that A divided by C is less than B divided by C. So let's go through another example of this. Let's say A is going to be 15. Let's say B is going to be 5. We know that 15 is greater than 5. And let's say C is going to be less than 0. So this time I'm going to say -5 is C. Stupid lights. And so now A divided by C has to be less than B divided by C. So we're going to say 15 divided by -5 is less than B divided by C, which is going to be 5 divided by -5. Well, we know that 15 divided by -5, that's -3. -3 is in fact less than -1. So this property does hold true. Okay, so just a couple properties to keep in mind about inequalities. There are things that we can do to inequalities, all right? And then these are the properties that kind of explain the rules behind the signs and the direction that the inequality faces. Okay, so let's go ahead and move on to the next page. So next page of number 1.4, we are going to write the inequality that represents the sentence. So kind of like we did in lesson 1.2, when we talked about how to convert words into mathematical symbols and numbers, we're going to do the same thing, but this time we're going to be using inequalities, so the greater than or less than signs. So for part A, the sum of a number and 7 is less than 15. The sum implies that you're doing addition, right? A number implies that you're going to have a variable, so I'm going to call that variable x, okay? And 7 is less than 15. Less than, of course, we're going to have that symbol. All right, so the sum of a number and 7. So I'm going to say some number x plus 7, the sum of those two, is less than 15. So that is what we're looking at here. Now let's look at part B. The product of a number w and 4 is at least 28. At least. I want you to think about what this means. Okay, we're going to think about that for a second, but let's do the other stuff first. The product of a number w and 4. So since we have the commas here with the w, that implies that the number that we're talking about is going to be the variable w, and we're looking at the product of w and 4. So we have 4 times w has to be at least 28. So that means it can be greater than 28. It can be equal to 28. But it can't be any less than 28. So that means 4 times w is going to have to be greater than or equal to 28. Okay? Again, at least means that it can be bigger, but it has to be minimum 28. So we have 4w is greater than or equal to 28. All right, moving on to part C. 8 less than a number is no more than 3. So let's first look at the first part of the sentence. 8 less than a number. Less than a number, we are going to be looking at subtraction, right? We are taking a number and we are subtracting off 8. A number implies that we're going to have some variable, so I'm going to call that variable x, all right? So 8 less than x is going to be represented by x minus 8. That's how we take 8 less than x. And that has to be no more than 3, which means it can be 3, but it can't be anything greater than 3. It can be less than 3, but it cannot be any greater than 3. So we're going to say that has to be less than or equal to 3. Finally, moving on to part D, we have the quotient of a number m and 6 is greater than 9. So the quotient, that implies that we're going to be using division here. The quotient of a number m, this is the number we're looking at. M is the variable I want you to use because it is signified. So we're going to take that quotient, m divided by 6 is greater than 9. So we know that value is going to have to be greater than 9. No funky wording there. That one is actually pretty straightforward when it comes to the wording. All right, let's move on down to example number 2. So now we're going to actually work into solving inequalities. Now, part of solving inequalities is we're also going to have to graph the solutions. So I'm going to show you how to do that down here. But what we're going to do is we're going to solve the inequality and graph the solution. I want you to solve this just as you would a regular algebraic expression, okay? So think of this right here as an equal sign. We're going to solve it the exact same way. The only time that this gets a little funky is if we have to divide by a negative. And if that happens, I'll just kind of show you what's happening. So if we have 5w minus 9 is less than or equal to 21, the first thing we're going to do is we're going to try to get w by itself. So I'm going to add 9 to both sides because I want to isolate the variable. So if we have add 9 to both sides, that's going to be 5w is less than or equal to 21. Now to get w by itself, I have to undo this multiplication. In order to undo multiplication, I divide by the number. So now these 5s are going to cancel out because I'm dividing 5 divided by 5. That's just 1. W is less than or equal to 21 over 5. And I made a mistake here because I forgot to add the 9. So that's actually going to be reverse 30 divided by 5. 30 divided by 5 is 6. I am not very smart sometimes. So W is less than or equal to 6. Thank goodness, because I was looking at that and I was like, that is not going to be a cute decimal. Why would she do this to us? So we're going to go ahead and graph this solution, okay? So in order to graph this, the first thing I want you to look and see if you have less than or equal to or just less than. If you have the equals underneath the inequality, that right there tells you we are going to have to include 6. And mathematically on the graph, we include 6 by putting a solid dot, okay? So the way I always remember this, if you see the line underneath the inequality, that means you're going to have a solid dot. So we're going to create a little number line here. All I'm going to do is I'm going to put 6 down here. You don't have to waste your time by putting a ton of numbers on there. Just go ahead and put 6. Now we're going to put a solid dot on 6 because remember, we have less than or equal to. So that means we're including 6 because we have the equal to. And we are going to look at all of the numbers that are less than or equal to 6. So all of the numbers that could fit into this inequality are going to be represented by this graph. All of the numbers to the left of 6 are possibilities that will fit that inequality. Okay? All right, moving on to example 3a. Now we have 8x minus 21 is greater than 75. So again, I want to solve this just like I normally would. So I'm going to try to get x by itself. First thing I want to do is add 21 to both sides. So I'm going to have, these are going to cancel out. They're just going to turn into 0. So I have 8x is greater than 75 plus 21 is going to give me 96. And then in order to get this variable by itself, I'm going to have to divide both sides by 8. If I divide both sides by 8, these two are going to cancel out. X is going to be left by itself. I have x is greater than, now 96 divided by 8 is just going to be 12. So now I want to graph this. The first thing I always look at when I'm graphing is what does my inequality look like, okay? My inequality does not have an equal sign underneath of it. So that means I'm going to have an open dot because we are not including 12. Not including 12. Okay? So if you had the equal sign, that means we would have a solid dot, but since we don't have the equal sign down here, that means we are just going to leave an open dot at 12. So on your graph, go ahead and put down 12. We're going to put an open dot at 12 because we're not including it. And we want to look at all of the values that are greater than 12. That's going to be all of the possible values for x. So x could literally be any number that is to the right of 12, okay? Because all the criteria that x has to fit, it has to be greater than 12. That's it. Moving on to 3b. We have -2 times quantity x plus 5 plus 9 is greater than or equal to 3. Now, here's the deal with this one. The first thing we want to do is we always want to take care of the parentheses that we see in the expression. Our end goal is, of course, to get x by itself, but in order to do so, we have to get it out of the parentheses. So what we're going to do is we're going to distribute this -2 to both terms inside. -2 times x is -2x. -2 times +5 is -10. And then we have the plus 9 on the outside is greater than or equal to 3. Now you might notice here, we have some like terms, right? We have -10 and +9. So what I can do to those two terms is I can combine those into one number. So this is going to turn into -2x, that one remains untouched. -10 plus 9, well, that's going to be -1, so I have -1 is greater than or equal to 3. Okay, now I want to work on getting x by itself. So in order to get x by itself, the first thing I have to do is add 1 to both sides. Whatever you do to one side of the equation, you must do to the other. We have -2x is greater than or equal to 4. Now, here is the deal. We are now going to get x by itself by dividing -2. Now, if you are dividing by a negative number, I want you to be very, 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 very careful. I'm going to make a huge deal about this. You must flip the inequality if you are dividing by a negative number. So I'm going to take this and I'm going to highlight the heck out of it to show that I have to flip that sign. So right here, I want you to go ahead and put flip. Make sure you flip it. Make sure it faces the opposite direction, okay? So now we have x by itself because the -2's get canceled out. We have x. Now, since I have that divide by negative, I have to flip the sign. So x is less than or equal to 4 divided by -2 is -2, okay? Be very, 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 very careful here. Whenever you divide by a negative, you flip. So I'm going to put right here, divide by negative, okay? So make sure you always flip when you divide by a negative. All right, so now let's go ahead and draw this on the graph. So I'm going to put -2 on this graph. Now think to yourself, is this going to be an open dot or a closed dot? Now, since I have, let me find another color here. Since I have this equals right down here, it's less than or equal to, that implies that you are going to have a closed dot. We are going to include -2, okay? So on your graph, go ahead and put -2 down here. We're going to put a solid dot at -2 because we are including it. X can be anything that is less than or equal to -2. So all of the possibilities for x are going to be down that way, okay? So always be very careful when you divide by negatives, please. Moving on to the next page, we have 3C. So this is number 3, part C. We have -3 times the quantity m plus 4 plus 8 is less than -13. Like we said in the last example, the first thing we always want to do if we have parentheses, we want to get rid of them by distributing that outside number. -3 times m is -3m. -3 times +4 is -12. And we have plus 8 is less than -13. All right, I have some like terms here, just like we did before. I have -12 and +8. I can combine those into one single term. This is going to become -3m. -12 plus 8, that is going to be -4, is less than -13. Now I'm going to get m by itself, so I'm going to go ahead and add 4 to both sides. We have -3m is less than -13 plus 4, that's going to be -9. Now, in order to get m by itself, this is where it gets tricky. We have to divide by a negative number. So I'm going to take both sides and divide by -3. Uh-oh. What's the big thing here? I am dividing by a negative. So I'm going to highlight the heck out of it, make sure I know exactly what needs to happen. If I'm dividing by a negative, I must take this symbol and flip it around. So I'm going to cancel out these negative 3's. I have m is greater than negative 9 divided by negative 3. If I have a negative divided by another negative, that's going to become a positive. 9 divided by 3 is 3. So I have m is greater than 3. Now, think to yourself, is this going to be an open dot or a closed dot? Well, since I don't have a line underneath this, I don't have equality here, I am not going to be including 3. So that means I'm going to be keeping this an open dot. Don't include 3. Okay, so on my number line, I'm going to put 3 down here. And I know that m can be anything greater than 3. So I'm not going to include 3. I'm going to put an open dot right here. All the possibilities for m are going to be positive values above 3. All right, let's move down to example number 4. Example number 4, we're going to write an inequality to solve the problem. So part A, the length of a flat screen TV is 16 inches greater than the width. The perimeter is less than 150 inches. We are going to describe the dimensions of the TV. Okay, so let's go ahead and take a look at what we have here. So first of all, we know that the length of a flat screen TV, so I'm going to call the length L. We know that the length of the flat screen TV is going to be 16 inches greater than the width. So I'm going to say the width is W, right, just to keep things simple here. And I know that that length is going to have to be 16 inches bigger than the width. So I'm going to say plus 16. The perimeter is less than 150 inches. Describe the dimensions of the TV. So this is the first thing I know. The second thing I know, the perimeter has to be less than 150 inches. Now let's think about how we should represent the perimeter. So if I have my TV right here, I always find that drawing a picture is usually the best thing to do, just to visualize something as you do it. So I'm going to say the length of the TV is going to be W plus 16. So the length of the TV up here is W plus 16. The length of the TV down here is W plus 16. All right. Now the width of the TV, I'm just going to call that W to represent width. So now the perimeter of the TV is going to have to be all of these things added up together. So if I have the whole perimeter, I'm going to have W plus 16 plus W plus 16 plus W. Remember, I'm adding all of those up together to find the perimeter. So I have some like terms here, obviously. My like terms are W, 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 and W. So I have 4 W's. And then my other like terms are going to be 16 and 16. Okay? So I have 4 W's plus 32. Okay? Now, we know that this perimeter is going to have to be less than 150 inches. So I'm going to say less than 150. Okay? Now, in order to solve for W and figure out what the dimensions of W are going to have to be, I'm going to first have to subtract 32 from both sides. Then I have 4W is going to be less than 150 minus 32. Well, that is going to be 118. Then to get W by itself, I'm going to have to divide both sides by 4. And I have W is less than 118 divided by 4. That is going to be 29.5. Okay? So I know that W, the width of the TV, is going to have to be less than 29.5 inches. Now, what about the length? I want to think to myself, what is the length going to be? Well, we know that the length is going to be W plus 16. So if I'm finding the length and what the length's dimensions are going to have to be, all I'm going to do is I'm going to plug in what I have for W right here into this equation. So I know that the length of the TV, and I still have my inequality here, is going to have to be less than W plus 16. So I'm going to have 29.5 plus 16. And that is going to be L is less than 45.5. Okay, so those are my two dimensions. Oh, don't forget to put your units here. Inches are what we're looking at. So those are going to be the dimensions of the TV. W, the width can be less than 29.5, and the length of the TV can be less than 45.5 inches, okay? So always draw a picture. I find that drawing a picture makes it a little bit easier. Simple definitions here, perimeter, that's the sum of all of the sides of a shape, all right? And then obviously remember our inequality rules. Moving down to part B, we have a digital movie service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? All right, well, let's go ahead and take a look at what we have here. So I'm going to go ahead and break this up into 2 different things, okay? So I'm going to say that A is plan number 1. I just want to make this a little bit more organized for myself. I'm going to say that B is plan number 2. All right, let's talk about plan number 1 first. So if I have plan number 1, A is equal to, we have a $9 membership fee and then $1 per download. Let's go ahead and assign a variable here. So I'm going to say that D is equal to downloads. I'm just assigning my variable so I know what I'm talking about. So for plan A, I'm going to have a $9 membership fee. So that's going to be $9 no matter what, plus $1 per download. So that's going to be 1D or just D. Now, if I'm talking about plan B, let's take a look and see what they have. Plan B has a $25 membership fee. So that's going to be 25 plus 50 cents per download. So 0.5 times D. Now what I want to see is how many songs must you download for the second plan to cost less than the first plan. So I'm going to say, how long is it going to take me for plan B to be less than plan A? So now all I have to do is I have to plug in those 2 equations that I just created in for B and A. So I know that B is 25 plus 0.5 times download. And that has to be less than 9 plus D. So what I want to do here is I want to get all of my variables on the same side, all of my constants on the other side, okay? So let's go ahead and subtract 0.5D from both sides. I want to isolate my variable, so I have to get all the variables on the same side. Those are going to cancel out, so I have 25 is less than 9 plus 1D minus 0.5D is just 0.5D. Then in order to get the variable by itself, I'm going to subtract 9 from both sides. 25 minus 9 is 16. That is less than 0.5D. Then to get D by itself, I just divide both sides by 0.5. Now, if I'm dividing by 1/2, that essentially means that I'm multiplying by 2. 16 divided by 0.5 is going to be 16 times 2. So I know that 32 is going to be less than D. So what that means is I have downloads has to be greater than 32. If I just flip those around, that's what that's going to look like. So what that means is I have to download more than 32 songs in order for plan B to be less than plan A. So in order for that to be true, what I have to do, I have to download 32 songs. Okay? So that's going to be what we're looking at here. We have to download 32 songs in order for that plan B to be less than plan A. All right, let's go ahead and move to the next part. This is the last page of our notes for today. Oh, no, we have a couple more. So if we are looking here at example number 5, we want to see, is this inequality always, sometimes, or never true? So what we're going to do is we're going to solve the inequality just like we normally would. And then we're going to go ahead and determine if it's always, sometimes, or never true. So for part A, if I see parentheses, I always want to distribute that number in. I have negative 3x, and then negative 3 times 7 is minus 21. That is greater than negative 3x plus 14. Now I'm going to try to combine some like terms here, get all of my variables on the same side. I'm going to go ahead and add 3x to both sides. Now, if I add 3x to both sides, this is going to cancel, but then also I have negative 3 plus 3. So this is going to be 0x on this side. So essentially, I don't even have to write it down. All I'm going to have on this side is negative 21 is greater than 14. Now, is negative 21 greater than 14? Is that a true statement? No, 14 is obviously a positive number. Negative 21 is a negative number. So since that inequality is not true, I'm going to say this is never going to be true. All right. Moving on to part B, I have 4 times the quantity 2x minus 3 is less than 8 times the quantity of x plus 1. If I distribute this 4 to both terms, 4 times 2x is going to give me 8x. 4 times negative 3 is negative 12. And that's less than 8 times x is going to be 8x. 8 times 1 is going to be plus 8. Now let me try to get all of my terms on the same side. So what I'm going to do is I'm going to subtract 8x from both sides. Now if I take positive 8x minus 8x, that's just going to be 0. So I'm left with negative 12 on this side is less than positive 8. Is negative 12 less than positive 8? Yes, it is, because negative 12 is a negative number. Positive 8 is a positive number. So that means since this inequality is true, this is always going to be true. There's never going to be an instance where negative 12 is not less than 8. All right, moving down to some rules here. So we're going to go ahead and say for and or inequalities, this is what we call compound inequalities. To solve a compound inequality containing and, find all values of the variable that make both inequalities true. If you have an and compound inequality, this is what the graph is going to look like. So if you have an and inequality, your graph is going to look something like this. So for example, if we had an inequality that said x is greater than 4 and x is less than or equal to 7, what's going to end up happening here? Let's say I have 4 right here and 7 right here. If x is greater than 4, that means that all of the values that are possible for x are going to be to the right of 4. And then if I'm looking at values that are less than or values that are less than or equal to 7, that means that all of these values to the left of 7 and including 7 are going to be possible values for that variable. So notice how these two overlap. What we're looking for, if we're looking for the and inequalities, these are going to be an overlap. Okay, that's what the graphs are going to look like when you have and inequalities. All of the values that overlap. To solve a compound inequality containing or, this time you're going to find all of the values of the variable that make at least one inequality true. Now, what we notice about some of the compound inequalities that contain or, these graphs are going to be a little bit different. These graphs are going to go in opposite directions. So if you have a graph of an or inequality, let's say we have m is greater than or equal to 3 and m is less than negative 4. If we have those two inequalities, here's the deal. Let's say we have negative 4 right here. Let's say we have positive 3 right here. If I'm looking at all of the values that are less than negative 4, that's going to be anything to the left of negative 4. If I'm looking at the values that are greater than or equal to, greater than or equal to 3, then I'm looking at all of the values that are going to the right of 3. So notice how these go in opposite directions. So these graphs, you're always going to be looking at opposite directions. Okay, just a couple of properties to note about these. All right, let's go ahead and move on to the next page. So let's solve each inequality and graph the solution set. So now we're going to work into compound inequalities for today. So we have 5 is less than or equal to 3x minus 1 and 2x is less than 12. We're going to go ahead and solve each of these and then graph the solution set. So Let's first look at the first inequality. We're going to solve these individually one at a time. In order to get this variable by itself, I have to add 1 to both sides. So I have 6 is less than or equal to 3x. All right, so now in order to get the variable by itself, I'm going to divide both sides by 3. If I divide both sides by 3, I'm going to have 6 divided by 3 is 2, which is less than or equal to 3 divided by 3 is 1, and I'm just left with x. Now let's go ahead and solve the second inequality. I'm going to do this in a different color. So in order to get x by itself for the second inequality, I'm going to take both sides and divide by 2. Then I'm going to have x is less than 12 divided by 2 is 6. So what I'm looking at here, I'm looking at 2 is less than or equal to x, or in other words, x is greater than or equal to 2. And I'm also looking at x is less than 6. So I have to do both of these at the same time on the same graph. So I'm going to go ahead and look for this. Now, what I want to do first, before I even look and see how this is going to look on the graph, I'm going to turn this into one single inequality, okay? So let's go ahead and move this up here. I'm going to write this as 1. So instead of having these two separate, I'm just going to write this as one big compound inequality. Since I have 2 is less than or equal to x, I'm going to write 2 is less than or equal to x first. X is going to go in the middle. And then I also know that x is less than 6. So I'm going to put x is less than 6. That's how I would represent these two as one single inequality. All right? So always look to see where you can put x in the middle if you have the word and. We're going to have x in the middle. So whatever value is less than x, that's going to go on the left-hand side. Whatever value is greater than x, that's going to go on the right-hand side. Let's go ahead and represent this with a graph. So if we have 2 is less than or equal to x, which is less than 6, I'm going to go ahead and put those two numbers on my graph. So I should have 2 on the left-hand side and then 6 on the right-hand side somewhere. So at 2, notice how I have a line underneath my inequality. That means that we are including 2. So since we have a line underneath, I'm going to say solid dot include 2. Okay, so we're going to put a solid dot here at 2. Now we're going to look at 6. Notice how 6 does not have a line underneath. So instead of putting a closed dot, I'm going to leave an open dot. Don't include 6. All right, so if there's no line underneath, we're not including it. So we're going to put an open dot at 6. Now, since x can lie in between those two values, here's how we're going to graph this. That variable can have any value in between 2, including 2, and 6, but we're not including 6. So that is how you would graph an inequality that is compound. Let's move on to part B. We have 7w minus 3 is greater than 11, or 4w minus 1 is less than negative 13. All right, so let's go ahead and put these separate. Solve for w, get w by itself. So what I'm going to do, I'm going to add 3 to both sides on this first inequality. So I have 7w is greater than 11 plus 3 is 14. Then on this side, I'm going to do this in a different color. 4w minus 1 is less than negative 13. I'm going to add 1 to both sides. I have 4w is less than negative 13. All right. Sorry, I'm adding 1, so that's going to be negative 12. My bad. Then I'm going to divide both sides by 4. W is less than negative 3. Now, since I have an or, I didn't even finish this one. Divide by 7. Divide by 7. W is greater than 2. So since I have an or up here, this or is going to go in the middle of the 2. W is greater than 2, or W is less than negative 3. If we remember back to the last page, we said that or graphs go off in separate directions, so we're not going to have overlap here. We're going to have opposite directions. So if we take a look at this, W is greater than 2. That is going to be the one that's going to be on the right-hand side. So let's go ahead and put these two numbers down on my graph. I have negative 3 and then positive 2 over here. Since I have W is greater than 2, this is going to be an open dot Once again, because there's no equality happening here, so we're not going to include 2. Okay, so I'm going to put an open dot at 2, and all the values that are greater than 2 are represented by W, so that's going to go off to the right-hand side. All right, W is less than -3. Now for this one, we are also going to include an open dot, and we're not going to include -3 because we don't have any equality happening here. So at -3, I'm going to put an open dot, and we're looking at all values for W that are less than -3. So we go off to the left-hand side. So that is how we would represent the graph of that compound inequality. All right, let's look at part C. So for part C, we have 16 is less than 5x plus 1, or 3x plus 9 is less than 6. Once again, we have an or compound inequality happening. So those are going to go off in separate directions, just like we had above. So let's go ahead and solve these separately. I'm going to subtract 1 from both sides. 16 minus 1 is 15 is less than 5x. Then I'm going to divide both sides by 5 to get the variable by itself. 15 divided by 3, 15 divided by 5 is going to be 3. 3 is less than x. I can also write that as x is greater than 3. I would actually prefer to have it written the second way. Then for the second inequality, I'm going to have subtracted 9 from both sides. Now I have 3x is less than -3. Divide both sides by 3. And I have x is less than -1. So my two inequalities are x is greater than 3 or x is less than -1. So I'm going to put those two numbers on the number line. I have -1 right about here, and then +3 I'll put right about here. It doesn't really matter exactly where you put them as long as they're in order. Then I'm going to go ahead and take a look at what I have. X is greater than 3. At 3, I'm going to have an open dot because there's no line underneath. So I'm going to put an open dot here at 3. And all of the values for x can be above 3 because x is greater than 3. Now I'm going to look at the second part. X is less than -1. Since I don't have a line here, I'm going to put an open dot at -1. And all of the values for x are going to be to the left because x can be anything less than -1. So those are my two graphs. Moving on to the last page of these notes, you guys have done so good today. Example number 7, we are going to start working into some word problems. So your 9 weeks grades for chemistry are 68, 73, 82, and 86. What is the lowest score you can earn on the final exam and still achieve a final average of at least 80? The first thing that we need to know about this is what is average? How do we represent average? The average of a set of numbers. We are going to take all of those numbers. So I'm going to say average. We're going to take all of those numbers, 68 plus 73 plus 82 plus 86. And we also want to include the value of the exam that we have not taken yet. So we're just going to say plus F. I'm going to say F represents the final exam. So this is how we would represent the average of all of those tests, including the final that we haven't taken yet. In order to take the average, we have to divide the sum of all of the numbers divided by how many numbers we are adding together. So we are adding 1, 2, 3, 4, 5 numbers. So we're going to take that and divide by 5. Now we know that the average we want to be at least 80. So this average, I want it to be greater than or equal to 80. Hey, I would be pretty happy if it was greater than 80 because that would mean good for my grade. So we're going to go ahead and add all these together and then solve and try to figure out what your final is going to have to be. So first, I'm going to go ahead and add up 68 plus 73 plus 82 plus 86. You plug that into your calculator, you're going to get 309 plus F divided by 5. So I've just added those four numbers together. That has to be greater than or equal to 80. Now, in order to get this variable by itself, I'm going to have to get rid of this fraction. I always get rid of fractions by multiplying by the reciprocal. So I'm going to multiply this side by 5. And I'm also going to multiply this side by 5. Okay? So this side gets multiplied by 5, and this side gets multiplied as well. So these 5s are going to cancel out. I'm just going to have 309 plus F has to be greater than or equal to 80 times 5 80 times 5 is going to be 400. All right, then to get f by itself, I'm going to subtract 309 from both sides. So I'm going to say minus 309, minus 309, and I'm left with f is greater than or equal to 400 minus 309 is just going to give us a total of 91. So what this is telling you is that your final exam has to be at least a 91% in order for you to get an average of 80. So you must get at least a 91%. Okay, so you want that final grade to be at least an 80. You need to get a 91% on the final exam. You can actually do that in this class too. Calculate your averages and figure out what you need to get for the final. All right, last example of the day. Example number 8, a worker is taking boxes of tile on an elevator. Each box weighs 62 pounds and the worker weighs 190 pounds. The elevator has a 3,000 pound weight limit. How many boxes of tile can the worker safely take on each trip? So what we want to look at, we want to look at, first of all, the weight of the worker. The worker weighs 190 pounds. We also want to look and see how many boxes, what the boxes weigh. The boxes weigh 62 pounds, okay? So the question is, how many boxes can I take on this elevator before it's unsafe? So what I'm going to do is I'm going to take the worker's weight, 190, then I'm going to add that to each box weighs 62. Now let's go ahead and assign a variable here. So I'm going to say B represents boxes. That's what I want to figure out, how many boxes I can get. So plus 62 pounds per box. So that's going to be 62B. All right. This number has to be less than or equal to 3,000. It cannot be any above 3,000. Otherwise, you will not be safely riding the elevator. So now we're going to get B by itself to try to figure out how many boxes we can take onto this elevator. So I'm going to subtract 190 from both sides. So if I subtract 190 from both sides, I'm going to have 62B is less than or equal to, well, 3,000 minus 190 is going to be 2,810. In order to get B by itself, I'm going to have to divide both sides by 62. So I'm going to take both sides, divide them by 62. Now, if you divide both sides by 62, you're going to have B is less than or equal to 2,810 divided by 62. That's going to give us about 45.323-ish boxes. So here's the deal. You obviously can't have 0.323 of a box. So what we're going to want to look at here, how many boxes can I take on the elevator? Well, if you take any above 45.323, it's going to be unsafe. So I'm going to go ahead and round down to be on the safe side. So I'm going to say you can take 45 boxes on the elevator. All right, if you take any more than that, it's going to be unsafe. And so 45 is the maximum you can take. All right, so you guys, that is our conclusion to lesson 1.4, all about inequalities. Please make sure you complete your homework assignment, and we'll see you back here next time.